List. A tour of C++, containers and algorithms. The standard library offers a doubly linked list called list. We use a list for sequences where we want to insert and delete elements without moving other elements. Insertion and deletion of phone book entries could be common, so a list could be appropriate for representing a simple phone book. For example, list entry phone book equals David Hume 123456, Karl Popper 234567, Bertrand Arthur William Russell 345678. When we use a linked list, we tend not to access elements using subscripting the way we commonly do for vectors. Instead, we might search the list looking for an element with a given value. To do this, we take advantage of the fact that a list is a sequence. Int getNumber, const string and s. 4. Const auto and x, phone book. If x.name equals s. Return x.number. Return 0, use 0 to represent number not found. The search for s starts at the beginning of the list and proceeds until s is found or the end of phone book is reached. Sometimes, we need to identify an element in a list. For example, we may want to delete it or insert a new entry before it. To do that, we use an iterator. A list iterator identifies an element of a list and can be used to iterate through a list, hence its name. Every standard library container provides the functions begin and end, which return an iterator to the first and to one past the last element, respectively. Using iterators explicitly, we can less elegantly write the getNumber function like this. Int getNumber, const string and s. 4. Auto p equals phonebook.begin. P not equal phonebook.end, plus p. If p arrow operator name equals s. To access members of a structure through a pointer, use the arrow operator. Returned p arrow operator number. Return 0. Use 0 to represent number not found. In fact, this is roughly the way the terser and less error-prone range for loop is implemented by the compiler. Given an iterator p, asterisk operator p is the element to which it refers, plus p advances p to refer to the next element, and when p refers to a class with a member m, then p arrow operator m is equivalent to asterisk operator p dot m. Adding elements to a list and removing elements from a list is easy. Void f, const entry and ee, list entry, iterator p, list entry, iterator q. Phonebook.insert, pee, add ee before the element referred to by p. Phonebook.erase, q, remove the element referred to by q. These list examples could be written identically using vector and, surprisingly, unless you understand machine architecture, perform better with a small vector than with a small list. When all we want is a sequence of elements, we have a choice between using a vector and a list. Unless you have a reason not to, use a vector. A vector performs better for traversal, example find, and count, and for sorting and searching, example sort, and binary search. Thank you for watching.